Now let's do a whole bunch of examples with inverse trig functions. So notice I've already written my chart up here, and this is half the battle for these problems. So notice specifically that I've restricted what I've put into sine, and I've restricted what I've put into cosine. So I've restricted the values of sine that I've used to the restriction of the domain of sine for when I take the inverse. So these specifically give me all the different possibilities for values of sine, and then I have the specific restricted domain of sine that gave me those values that I've chosen to use for the outputs of my inverse. So here are the inputs to my inverse, my sine inverse. Here are the outputs, and that's the correct range that we were expecting. Same thing with the cosine. So here are the outputs of cosine in the restricted domain that I've chosen to take the inverse from. So thinking of that from the inverse side, here are the inputs of my cosine inverse function, and here are the outputs. And this is the range that I'm expecting, from 0 to pi. So I've been really careful to put in only the values that I specifically need so that when I go, I know that I'm already getting the right value out. I'm already within that restricted range. I know that I have the right value. So that's the hard part. Now it's just a matter of looking at our chart, figuring out where, for instance, 0 happens as a sine value, and getting the angle. So let's take this one, sine inverse of 0 or arcsine of 0. So I need to find 0 in the sine row of my chart. Well, it happens right here. The square root of 0 over 2 is indeed 0. So this is where the sine of some angle is equal to 0. So that's the angle I want as my output to my inverse. So 0 is my answer here. We can do the same thing with cosine inverse. So if we want to take the cosine inverse of negative square root of 3 over 2, I look at my cosine row now. I find the negative square root of 3 over 2. So this is where cosine of some angle is equal to the square root of 3 over 2. This is the angle where it happens. So this is my answer to my inverse. So I've evaluated it to be 5 pi over 6. Okay. Cosine inverse of 1. Same deal. I'm going to find 1 in my cosine row. Square root of 4 is 2, so 2 over 2 is 1. So that happens at the angle 0. So that's my output for cosine inverse of 1. Okay, so for sine inverse of 1/2. So I go back to my sine row. 1/2 is right here. So that's where sine of theta is equal to 1/2. That theta was pi over 6. So pi over 6 is my output for sine inverse. That was the angle whose sine was 1/2. So cosine inverse of negative 1/2, follow my cosine row. Here's where negative 1/2 happens. It happened at 2 pi over 3. Then we have sine inverse of negative square root of 2 over 2. So I'm back to my sine row. Here's the negative square root of 2 over 2. It happened at negative pi over 4. So that is my answer there. What about sine inverse of negative 1? Well, if I go along my sine row, here that is. That's where it happens. It came from negative pi over 2. So that's my output to sine inverse of negative 1. What about cosine inverse of root 2 over 2? So I follow this row. Here's root 2 over 2. It happened at pi over 4. So that's my output. So these problems, these first 8 problems, are all about knowing these values, knowing the cosine values for all our special angles and the sine values for all our special angles, and being able to work backwards. So being able to pick out which angle gave me that value, and making sure that we're in the right range. We're getting an angle between negative pi over 2 and pi over 2 for sine inverse, and an angle between 0 and pi for cosine inverse. So one of the other things we can do with these cosine and sine inverse functions is we can compose them with cosine and sine. So if I take cosine of cosine inverse of root 3 over 2, well, let's just find cosine inverse of root 3 over 2 first, one step at a time. So cosine, here's my row, I want root 3 over 2, that happens here at pi over 6. So what I'm saying here is I want the cosine of pi over 6. So now I'm going to go back to use my chart the other way. I'm going to go back to my input, say, okay, I want pi over 6, cosine there is root 3 over 2. Now notice that I just basically did something and then undid it. I found where cosine was root 3 over 2, figured out that was pi over 6, then I found pi over 6 and figured out what the cosine value was. That's the design of a function and its inverse. When we compose them, they're supposed to undo each other. So we should be getting the same thing as our input and our output, which we did here, so that's good. I can also take sine inverse of sine of pi over 4. So let's work again from the inside out. Sine of pi over 4, so pi over 4 is right here. Sine of that is root 2 over 2. Okay, so now we need to look at our sine row. Root 2 over 2 happens here, and that came from pi over 4. So again, we got the same output that we had as our original input because we're composing a function and its inverse. That's the design of the inverse function, to do that. But it's not always true that that happens, unfortunately, with these functions because we had to do so much restricting when we defined them. So let's look at this example. So we don't quite have enough of our chart filled out to get this, but let's fill in more. So we were at root 4 over 2 here, so we're going to count back down. Root 3 over 2, root 2 over 2, root 1 over 2, root 0 over 2. So the cosine of negative pi over 2, so here's negative pi over 2, the cosine of that is the square root of 0 over 2. Well, that's 0. So now we just need to take the cosine inverse of 0. But notice suddenly I have 2 zeros in my chart. So I need to think really hard, be really careful, because this could be the answer or this could be the answer. Cosine at both of those points is 0. But we need to be really careful because we know that when I take cosine inverse, I'm only going to get angles between 0 and pi. Negative pi over 2 is not between 0 and pi, so I have to go with this occurrence in my chart. It has to be pi over 2. So essentially what I had to do here was I had to figure out what cosine of negative pi over 2 was. I did. That was 0. Then I needed to think of another angle that's in the correct range from 0 to pi that had that same cosine. It happened that pi over 2 did, so that became our answer. So these types of problems, if the input is already in the correct range for sine inverse or cosine inverse, then we're golden. It just comes out. If not, we have to be really careful. We have to find an angle that is in the correct range for cosine or sine inverse that has that same value, the same cosine or sine value. So for instance, if we take sine inverse of sine of 5 pi over 2. Well, I'm not going to continue my chart out to get to 5 pi over 2 because I don't have enough space. If you want to, you can. If I kept going, I could get that value, or I can think of going back to my unit circle. So let's think about where 5 pi over 2 would be. So I go 1 pi, 2 pi, so that's, well, So I go 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So this right here would be my angle once I've gone around the circle once. So I'm hitting the unit circle here, so that means that my sine value would be 1. So you can think about this on the unit circle, or you can think about extending your chart out as far as you need to get to it. So I figured out my sine value for 5 pi over 2 was 1. So now I need to go back to my chart for sine inverse. So I need to find where positive 1 happens. Well, that happens at pi over 2. And that is still in the correct range for sine inverse, so that's going to be my answer. So I found another angle that had the same sine value as 5 pi over 2 did, and that was my answer. So once we get to this point, we need to be really careful about making sure that the output we're getting is always in the correct range for sine inverse and cosine inverse. Otherwise, these problems are quite simple because the input just becomes the output.